Okay, hello dear teams. My name is Elisa and I am presenting topic 5, the bacteria. Okay, next slide. States prepare sterile culture dishes and investigate the growth of door handle bacteria and other common microorganisms and investigate how various disinfectants such as antibacterial soap affect the bacteria. So, our test was conveyed by the theory of the Kirby-Boyer antibiotic test, which states that the bacteria are spread around a petri dish, a disinfectant is added upon them, disinfectant spreads out to the bacteria, creating an inhibition zone, next slide, which is the area in the petri dish where the bacteria is dead, as in not alive. Thus, the disinfectant is efficient and the bacteria is killed. Next slide. So our first experiment was to certainly test this phenomenon. Our independent variables are the types of disinfectant, concentration ratio of the disinfectant, types of bacteria, and our dependent variable was the diameter of the inhibition zone. Next slide. And our control variables were the temperature of the incubator, which stood at 37 degrees Celsius, size and type of sterile paper discs, which was 6 millimeters, volume of bacteria solution added to the disc, type of the agar, which was the soy agar, and the incubation time, which was 24 hours. Next slide. The research question was, how does the diameter of the inhibition zone change in 4 different bacteria colonies when planted in the petri dishes with 5 different types of disinfectants? My hypothesis was that the bleach will be the most effective disinfectant since it has 7 valence electrons, making it very reactive, and hypochlorous acid, which causes the denaturation of the proteins in the bacteria, which causes to them dying. Some of the materials I used were 80 petri dishes, 4 types of bacteria, 2 of which were unknown, and 5 types of disinfectant. Next slide. And next slide. So on my method, as I stated previously in my theory portion, I've planted 4 different bacteria on individual petri dish, which were spread around. Then a disinfectant was applied in different dilutions by dipping a sterile paper disc into a assigned disinfectant and placed around a petri dish. This was our first trial. In the second trial, they were placed around. Next slide. And next slide. And next slide. Next slide. In the previous slides, you could see the data charts. Here in graph 1 and graph 2, we can see the effects of the disinfectants on the unclassified species white and unclassified species yellow. As you can see, the bleach was the strongest one. In the next graphs, graph 3, graph 4, we can see the effects of the disinfectants on Escherichia coli as well as Staphylococcus aureus. Once again, we can see that the bleach was the most efficient disinfectant of all. And here we see the overall effect of each disinfectant on the bacteria. In conclusions, the most efficient disinfectant was bleach, which proved my hypothesis, with the highest inhibition zone of 27 milliliters. The disinfectants by order of efficiency was bleach, followed by antibacterial soap, followed by ethanol, followed by ammonia, followed by vinegar. The higher the dilution proved to be, the less antibacterial effect. Therefore, the more we diluted the disinfectant, the less bacteria died. The vinegar was only effective in unclassified colony yellow. Ammonia was only effective in the unclassified colony white. Non-diluted ethanol was more effective than the antibacterial soap for the Escherichia coli, but not for Staphylococcus aureus. And in total, we have conducted 80 tests. Okay, evaluation. Possible uneven distribution of bacteria on the petri dish, possible uneven distribution of the disinfectant on the sterile paper disc, and improvements testing more dilutions against wider area of bacteria could prove better. Experiment 2 was gram stain test. Here we're trying to find out what kind of bacteria we have gotten from the door handle. Next slide. You can see our bacteria here, which were the classical dyes and the 2 unclassified bacteria, as well as clean glass slides. Next slide. So first, blue stain was applied, which was the crystal violet stain. Then application of iodine happened. Then the 2 bacteria were rinsed with alcohol. Here you can see the procedure in the pictures. In conclusion, both specimens appeared to be purple. That after the gram stain test, both specimens were not decolorized by ethyl alcohol, thus they were stained purple. And the purple color signifies that both colonies are gram-positive, which you can see in the results here. Next, our third and last experiment was the catalyzed test to investigate whether the unknown bacteria were catalyzed positive or catalyzed negative. For that, we used hydrogen peroxide and the 2 unclassified bacteria. The 2 unclassified bacteria were placed on a sterile glass plate, and then the hydrogen peroxide was applied. In the results, the unclassified colony yellow rapidly produced bubbles, and so did the unclassified colony white. Therefore, they're both catalyzed positive. And judging by the previous 2 tests, we can see that the unclassified colony yellow was gram-positive, catalyzed positive. It's found on human skin, hence taken from a door handle, and it was arranged in tetrads, which was seen from the microscope. Thus, it belongs to the Kakuria family. Whereas for the unclassified species white, once again, it was gram-positive, catalyzed positive. Once again, found on human skin, hence we took it off of a door handle. Arranged in clumps, which was seen under the microscope. Therefore, it belongs in the Staphylococcus family. Evaluation, once again, we could have uneven distribution of the hydrogen peroxide per bacterium, which could have affected the creation of the oxygen bubbles. Therefore, once again, we only tried 1 experiment per bacteria colony. Therefore, we could have more trials to improve my results. Next slide. Okay, that's my bibliography. Thank you.
Thank you very much. Now we proceed with clarifying questions of the opponent to the reporter.
Christoph, stay there.
Thank you very much for your presentation. Although I do have some questions for you. First of all, are there any other parameters that you took into consideration for your experiment that you didn't mention on your presentation?
No, I mentioned that I took the parameters such as temperature and the time in the incubator.
Okay. So for how many days exactly did you conduct the experiment?
24 hours.
24 hours, okay. Did you measure the pH of the disinfectants you used?
That was not one of the parameters tested.
Okay. You said that the temperature, the environmental temperature was, if I'm not wrong, 37 degrees
Yes.
Celsius? Okay, so why did you consider changing the temperature so you can see how many, how the microbes will react?
Thank you. Can you scroll 2 slides down, please? Down. Down, down, down. The other way down. The other way, Crystal. The other way. Lower, lower, lower.
You can
Next slide.
to me.
So here I done some research, and 2 of the known bacteria were mesophilic, meaning that they are active and alive at 37 degrees. Therefore, I can predict if the temperature was different, we would either have lower amount of bacteria.
Are you familiar with the bacteria growth curve?
No.
Okay, bacteria growth curve is actually a gram of how bacteria are growing up in our environments. And there we see the...
Do you mean the lag
phase?
phase?
Yes, exactly.
2 slides up, please.
The log phase and the X phase. Did you investigate in which way the disinfectants infect the bacteria growth curve? I mean, the death phase was much sooner or much later?
No, the bacteria... Yes, here we go. So the bacteria was essentially applied in the stage where the disinfectants were essentially applied at the stage where bacteria is already hatching and growing and is at its finest. Therefore, we could have more accurate results.
Okay, so could you explain your experimental procedure? How did you select the microbe? The experiment said, the statement of the experiment said we have from a door handle. Did you do that?
Yes, as I stated before, I did do that. And my 2 unclassified species were essentially from a door handle.
Okay, so could you repeat again which microbes did you find? 4 kinds?
Scroll up, please. So the 2 of the known bacteria were Staphylococcus aureus and Escherichia coli. Up, please, to my results. So, and the 2 unclassified bacteria...
Okay.
You have 3 minutes to prepare your opposition.
Actually, we can leave it here for later.
Και μετά το statement.
For which question?
Γράψε
Okay, let's take
clarifying
our
questions.
USB.
Γράψε clarifying questions.
Yeah, I'll show you now. Let's go.
Congratulations.
Thank you.
Και για τον opponent.
I have it in my slide.
Did you take care of the thing that the petri dishes were upside down in the incubator?
Yeah.
Okay, why was that?
It was just the placement of the petri dishes.
Very well. Continuing to the opponent. So you insisted on the pH level of the media. Why is that?
Okay, basically, the reason why I insisted so much on the pH of the substances, the disinfectants, was because many microbes do not stand the acid price on pH, under of the price 7 on 25 degrees Celsius. Although she did mention that the temperature was 37 degrees, so the pH wasn't exactly the estimated. We investigated.
Would that imply that the pH level?
Well, actually, it
different
can
with
affect the disinfectant because, as I said, if we have acid price of pH, the bacteria cannot be, they cannot grow as they estimated.
Okay. Reporter, wasn't the culture media consistent?
Yes, it was.
Miller Hinton, right?
Yep.
So.
Time's up, thank you. We have 2 minutes to prepare your
It's-
review. Time's up, thank you.
Okay.
Okay.
Okay, reset the clock.
Okay, we apologize for our technical issues. My name is Nicholas Masuk, so I'm going to present you. I'm the reviewer of disinfectants. The reporter, she had a very thorough presentation. She conducted a very well experiment, and it was finished. She tested and distinguished bacteria types. She found and proved it with tests, such as the Gram test. She tested a considerable amount of disinfectant types, and there were excellent speaking skills. Now, there were some cons as well. There were no errors explained, and that's a point the esteemed opponent made. The conclusions were not specific, although they confirmed the hypothesis. A bit confusing presentation, because it was very packed. Continue. The opponent, she recognized the pros of the reporter. She noticed that there were no errors explained, which is a very good, as we said, a good point, as we said. She was relatively polite, which is basically pro, but could be a con as well. She didn't mention all the parameters that were experimented. In the discussion, the reporter made an relative argument, which was the pH of the culture media, but the culture media, as the reporter explained, is specific because the culture media has a specific pH of level by the factory, which is produced. The opponent insisted, for the pH. She had a very our opinion is with the reporter because she had a very thorough presentation and full of experiments that exceeded our expectations, and especially the reporters, the opponents, sorry. Yeah, the pH was irrelative, and the temperature, as the reporter said, was constant because of the incubator, of course. Now, points missed. There were some points missed as well. We highlight that all the points that were missed from the reporter and the opponent were equally important, and maybe a big mistake by the reporter and the opponent was that, no, sorry, that's yeah. The parameters were a flaw, a big flaw of the opponent. She shouldn't have insisted so much in the parameters, and she should have admitted that the reporter's presentation was full and she had tested all the parameters. Thank you.
Thank you very much. Let's proceed with concluding remarks of the opponent.
Thank you all. Okay, I would like to thank you all for this amazing fight, but I would like to mention some of my points. Actually, both the reporter and the reviewer mentioned that the pH of the disinfectants and other substances on the microorganisms did not affect them. But actually, microbes and microorganisms in prices under the price of 7 of the pH cannot grow with the estimated time, and the bacteria growth curve is actually lower. The death phase comes sooner, and the bacteria are too weak to grow. Also, I would like to mention that we did insist on the parameters that the reporter has missed, because it's actually how the experiment works. We have to test all the parameters for the microbes to grow. If we don't allow microbes to grow, then we don't have an experiment. Thank you very much.
Concluding remarks by the reporter.
Okay, so I have several concluding remarks to be stated. So first of all, the pH was controlled by the soy agar that was used, as I stated earlier. The theory is not my obligation to explain. I have touched upon it for everybody present in the room to be able to understand what the experiment was about. And some slides were skipped through since the data was then presented on the graphs in the end. The parameters were referred to in the beginning of the presentation, and I clearly stated which ones I would be focusing on. No experiment is perfect. Not all of the parameters can be always tested. As also at the end, I have presented some of my errors, and thank you very much for your attention.
Thank you. Now we have time for some clarifying questions by the jury to all speakers. Does anyone want to ask something? Mr. Voulias?
I would like to ask the opponent first.
Please stand up.
Yes, of course the conclusions are the most interesting. You mentioned that her conclusions were interesting. By the same time, you said that they were chaotic. How could this be possible?
Exactly. As I mentioned, her conclusion was quite interesting, but as they were too much on the same slide, we couldn't exactly follow the conclusions that they were quite impressive, but the way she presented them, we weren't able to follow, so they're chaotic. I think I've covered
You mean the structure, not the
Exactly.
results?
Yes.
Okay, thank you very much. Okay, that's all.
Okay, thank you. We now have some time for the jury to make their remarks.
What is our next role?
Πρέπει να κάνουμε. So the jurors, please raise your marks for the reporter. 23, 23, 24, 26. Thank you. Okay. Now please show your marks for the opponent. Show your marks. 17, 17, 18, 16. Thank you. And now for the reviewer. Seven, 7, 8, 9. Thank you very much. Now, would you, any of you would like to make some comments about the fight?
Okay, concerning the reporter, you managed to defend your solution very well. Of course, you have excellent speaking skills. Concerning the opponent, you did a great job. You made an excellent analysis of the report. The review, concerning the reviewer, beside his technical problems, that was really serious, you made a very well analytical review. Excellent.
Right. About the reporter, the only problem, as everyone else said, is about the structure of your presentation. The structure of your presentation. I was also lost on your conclusions, and that's where you lost your point from me. And I don't have anything else to add to the opponent or the reviewer.
Thank you all very much. We now finished stage 1. We have 10 minutes break, and we'll be back here for stage number 2. Thank you.
Time.
We now start stage 2. The reporter is ready.
My name is Evangelos Kadas. I'm from Anatolia College, and today I'm going to present you the second problem of IYNT 2020, slow match, in which the flame from propagates with a constant low speed has been important. Ignite can produce such cores and investigate their burn rates and other properties. Time-blasting fuse. A time-blasting fuse transmits a delayed speed of flame to a non-electric blasting cap. The delay allows the person to get to a safe distance before the explosion. Potassium nitrate is a chemical compound with the chemical formula of potassium, nitrogen, oxygen 3. It is an ionic salt of potassium ions K+, and nitric ions NO3-. Major use of potassium nitrate are in fertilizer, molecular stamp removal, and rock. It's one of the major consequences of gunpowder. It's one of the major consequences of gunpowder. I chose potassium nitrate because it's not viable. It is the most viable option as it was used by soldiers in the 14th century. Cotton, it is a soft, fluffy staple fiber. The fiber is almost pure cellulose. In addition to the textile industry, cotton is used in fishing nets, coffee filters, tents, and explosion manufacture. So the concept of my experiment, I will produce different types of time-blasting fuses with differences in the type of the core, the diameter of the core, and the composition of the solution that has infused the core. I will collect data, compare it, and examine whether my hypotheses are true or not. So I have two types of cores. The first one is 100% cotton, and the second one is 60% acrylic, 40% wool. So type B is a very usual type of strand used in sewing or weaving. So the different types of diameter. I'll have a cotton core 1 millimeter diameter, a cotton core 8 millimeter diameter, and an acrylic and wool core 8 millimeter diameter. Here is the content. And so the ratio between potassium nitrate and sugar is 1:1, 3:2, and 3:1. So the production process. First of all, I prepare the solution, then warm the solution to a boiling temperature and continue to stir. I will throw in the cords and continue to stir slowly for 5 minutes, and then I will remove the soaked cords and place them in a suitable container without touching each other. Then I will place the pan in an air oven at 150 degrees Celsius and dry them for 20 minutes. The core slow burning fuses are ready. Here is the production process and measurements. So my principle, only when I have all three materials at the same time, fuel, oxygen, and heat or fire, the fuse cord will continue to burn. The fuel is cotton and sugar, and the oxygen is the decomposition of potassium nitrate. Here are the measurement and accuracy errors. So my first hypothesis. The type of the core directly affects the burn rate. Here is the data. So the independent variables are the core and diameter. The dependent are the burn rate on core and measured in seconds, and the constant is the environmental conditions. Here's the data. The stops that you see and the explosion ones means that the fuse stopped or exploded. So here are my results in diagrams. Numbers 1 to 6 are the fuses. The ones that are missing stopped or exploded. Here are more diagrams. So my conclusion is that from measurements I found out that cores with the same thickness and production solution but different cores, they had different burn rates. And cotton was much better material than wool and acrylic as the core because it had to burn the time-blasting fuse. So cotton had no stops, and always cotton had higher burn rate than wood and acrylic. So my hypothesis was true. So my second hypothesis is that the diameter of the core directly affects the burn rate. The independent variable is the type of the core, and the dependent and constants are the same with the previous hypothesis. Here are more diagrams. Here there was one that exploded, and then more diagrams. So my conclusion is that I found out that cores with the same type of core and production solution, but different core diameter, they had different burn rates. So in the 1 millimeter core, we had 3 stops and 1 explosion. So a very thin core, because it does not absorb much of the solution, it has little fuel, it is likely to fail. So always the cotton core 8 millimeter had higher flame than 1 millimeter. So my hypothesis was correct. My third and last hypothesis is that the type of the solution directly affects the burn rate. The independent variable is the type of the core and diameter, and the dependent and constants are the same with the previous experiment hypothesis. Here are my diagrams. As you can see, the ones that are missing stopped. Here are more diagrams. Here's the one that exploded, and more diagrams. So my conclusion is that from the measurements I found out that cores with the same type of core and diameter but different type of solution, they had different burn rates. So the most balanced type was type 2:3:2 ratio. So cotton core with a constant burn rate per type. So the burn rate was 1.29 seconds per centimeter, 1.39 seconds per centimeter in the 8 millimeter core. So my conclusion that high potassium nitrate and fuel ratio can cause explosion or a rapid uncontrolled ignition. The wool and acrylic core had failures and confirms that it is not preferred. and the constant burn rate with high flame confirms that the choice of materials and solutions was successful. So here's a little video. So my final conclusion is that the acceptable time for a time-lasting fuse must have a core diameter between 4 to 8 millimeters, a core from cotton, a ratio between potassium nitrate and sugar should be 3 to 2, and after all, the expected burn rate will be between 1.3 to 1.6 seconds per centimeter. Here are my bibliography and sources. End of presentation. Thank you for your time and attention.
Thank you very much. Now we proceed with the phase of clarifying questions by the opponent.
Right, thank you for presenting. How were the snow matches dried?
So they were dried, as I said, I put them in the oven with air drying, so the air was really hot.
Were they dried horizontally or vertically?
Yeah, they were dried like they were left in the pan and dried. So
Dried. Okay, do you think that because, excuse me, did you burn all the snow mats the same day?
yeah.
Yes.
Yeah,
Were the weather conditions recorded?
Yes, no, I didn't conclude in my experiment. I didn't include them, but yeah, I know that the humidity and the temperature have an effect on my experiment and the wind.
How were the snow mats stored?
How were they stored?
Yeah.
When they were dried, I did the experiment, so they.
Okay. Do you believe that by having a mixed concentration of the same concentration of the other variable is an effective change to
Could you repeat your question? I didn't understand it.
Okay. Do you think that a solution that is mixed with the first solution is a clear identifier with different concentrations?
No, I don't believe it.
You do not believe that? Did you research on other properties of the slow mats? Because it was asked in the title of what it was asked by the IYNT was other properties. What were they researched, tested?
No, I didn't do further research than the one that I concluded in my experiment.
So, do you know, have you recorded the actual burn rate? Have you written down in your presentation the actual burn rate?
You mean like how much it took for a core?
Yeah, exactly.
So these are the seconds.
These are the seconds, but this is not a rate. Anyway, that's it. I'm done with my clarifying questions.
Thank you very much. Very good.
Okay, so should I download the slide? Is it finished? So, slide 2. Okay, is it ready?
Δεν το θυμάμαι, παίξω τώρα.
Okay.
Αν μιλάω από εδώ, μ' ακούς που μιλάω δυνατά.
Who won? Who's going to change? 5. Present.
10 seconds. Are you ready?
Yeah, now I'm ready.
Okay, please proceed.
Okay. Welcome everyone. My name is Pavlos. Today I'm representing Pinewood, and I'll be opposing on the topic done by Anatolia for the second topic, slow mats. First of all, we start off with a theory. Its strengths were that the properties of slow mats were said. They talked about potassium nitrate and mentioned some materials. However, mentioned why the slow mats behave that way, and also did not mention the chemical formula that happens during combustion, which is really important. Is why it's ignited. Also, type B chemical, type B type of core was mixed, and it's not a clear indicator for a conclusion. And overall, it was messy and confusing. Strength tested many parameters, such as diameter, solution, and concentration. However, it did not explain the tables and diagrams. It just showed them and moved to the next slide. Reads off the slides without any eye contact with the audience. And also, the hypothesis was confusing. It was not clear. The experiment mentioned all 3 variables, did not consider environmental conditions as wind and humidity and control into as an error, which is a huge mistake because it affects a lot. It affects the burn rate a lot and makes the slow mats burn unevenly, which is one of the 4 basic properties. And now, speaking of properties, one of the properties of a slow mat is also a flame. It should not have a flame. As we saw in the video, there was clearly a flame, a spark, which is it should not have been there. Graphs were presented. My bad. Columns were presented. However, graphs, because it's a rate, we investigate the rates of a slow mat. Graphs could be a linear graph could be used to represent a speed. It could be much clearer, and it could be also used for comparing every trial. Also, the graphs have no axis, inappropriate graphs were chosen, and also conclusions were messy and confusing. Evaluation, no errors were presented. There was no clear evaluation at the end of presentation, and also no improvements to the experiment proposed. Now we move on to the points of discussion.
Reporter, please step up to the stage for the discussion part.
In your weaknesses, you said that no errors were presented.
Hold up. I'm the one asking questions. Why wasn't the burn rate chosen? Only the seconds were present in the presentation, but it stated clearly in the title of the problem that the burn rate should be present.
Oh, okay. I actually presented some of the I agree with you. I didn't present all the burners, but I presented some of them in one of my hypotheses.
Okay. is a hypothesis. Hypothesis not for concluding and viewing data. Hypothesis is for hypothesizing how the experiment will evolve. However, the hypothesis was not clear. Hypothesis, do you believe that, how do you believe that the diameter of the core affected the results?
The diameter of the core, the thicker the core, the slower with the fire burn, because it got more
Why?
thing to burn,
Why?
more stuff to burn.
Why?
As I saw in my experiment, because
Okay.
the small the cotton core, 1 millimeter. it
Okay,
burned
okay.
1.8.
So the actual reason why the parameter, the diameter is affecting the burn rate is because of collision theory, and because of the burn rate. A thicker core has more surface area, so combustion occurs slower. I think it's a huge error that you do not refer to combustion, which is the chemical reaction happening at that time. Why did you boil the matches?
Why the balls so I could melt the solution? So first of all, I will boil the matches so the solution. I boil the matches so they can melt the solution, can get them easier.
Not exactly. The reason why we boil the matches, in our opinion, is because a potassium nitrate is an aqueous. So it's better, of course, for the action to occur, better to be evenly distributed in all around the slow mats. So another question about the drying. Do you believe that the way you dry the slow mats was? Do you believe that there are any errors for the drying method?
I believe one mistake is that they actually touched something. I believe the only error that I have there, because maybe they could get stuck. Some of the potassium nitrate or sugar could get stuck.
Yeah, that's why. It's one of the basic properties, one of the 4 basic properties of slow mats is to burn evenly. If potassium nitrate is not evenly distributed in the slow mat itself, the burn rate is not even. Did you have to reignite the slow mats?
No, I didn't reignite anything. As I saw in my presentation, when the fuse stopped, I said it stopped or exploded.
Okay. Do you believe that your graphs represent your data properly?
I believe this. I don't know if this was the most effective graph, but they were certainly effective.
Yeah, it was not the most effective graph, in our opinion, because its speed and its rate. It could be represented as a linear graph, and also you could put the points and also use the line of best fit to see how even each part of slow mats was burned. It's really important to be evenly burned. There was no reference of evenly burned of the slow mats being evenly burned in the presentation, which I think it's not good. In my opinion, I believe that I really believe that the trials tested the parameters tested were good. However, the execution was not good. There were many faulty errors. Could you please excuse one of these errors?
So I didn't have a certain how to say place where I wouldn't light the matches inside. I lighted them outside, so I didn't have a secure.
Oh, you light them
place
outside.
for
You lit them outside. So weather plays a condition, right? If you lit them outside, weather changes.
As I said, weather can affect it. I said it before when you asked
Weather
me a
can affect
clarifying
how?
question. Well, if there is a high wind or high humidity, because once I tried and then I canceled the experiment because they wouldn't ignite.
Okay, that's enough. I'm done with questions.
Thank you. Please stay there. Please stay there. The reviewer will ask the clarifying questions.
Thank you both for the presentation and your discussion. It was very interesting to watch. However, I have some questions. First of all, for the reporter.
Please speak louder.
Yeah. You used sugar in one of your solutions.
Yeah.
Why?
No, I have a solution. I use sugar, but different percentage. Because sugar would act as like more fuel and would make the roller go faster.
Okay.
Give her your mic.
that more in depth?
So the properties of slow mats and how a slow mat should behave to be successful is to burn evenly, slowly, to live up of its name, reliably, not to put out, and also no flame. No flame plays a huge role.
Okay. How long? I'm not sure if you mentioned that, but how long did your solutions? Did your cord stay in your solutions? The cords that you used, you put them in a solution, right? How long did you immerse them in that solution?
Up to 1 hour.
An hour, okay. So what do you think would happen if you had left that for a shorter or longer period of time?
The times would be different. Times maybe faster or slower, but I haven't tested it.
Okay. Thank you, both of you.
Thank you. You now have 2 minutes to prepare your review. Guys, speak louder, please. Speak louder so
Speak
they can
louder.
track your voice. We're okay. Δεν ανοίγει, είναι πάντα ανοιχτό. Είναι πάντα ανοιχτό.
My bad. Excuse me.
Μικρό.
How did I do?
Είναι στον Παύλο συνέντευξη. Το ύφος. Το ύφος των ερωτήσεων. Αλλά Δημήτρη λέγει. Μόνο εγώ μιλάω δυνατά έτσι και ένα μικρόφωνο να μην είχα θα μ' ακούγες.
I am ready to start if you are.
Are you ready?
Yes.
Okay, let's begin.
Shall I start? Okay. Ladies and gentlemen, my name is Parmai Christina. I'm from Team
Louder.
Friganiotes, and I'm here to review problem number 2, which is slow match. We saw an interesting presentation from the reporting team and an interesting discussion between the reporter and the opponent. So first of all, with the reporter, he had some very good and some very bad points. First of all, he gave a really clear and good definition of the phenomenon. His presentation was structured well, and the experiments well conducted in a good way. The results he presented were interesting, and he justified the conclusions. And there were some graphs and tables actually that really helped understand the experiment more. However, there were some cons. First of all, the problem statement it was not explained. He added some unnecessary theory on the phenomenon. The hypothesis was at the end of the presentation, which made it harder to watch. It should be in the beginning to basically keep in mind what we will be watching and to eventually see if that hypothesis was right or wrong. He did not explain the usage of certain materials, like the sugar that I asked him about. He did not include certain parameters, such as like the residence time of the core. The experiments were conducted in a non-controllable environment. He did not explain the errors he could have had. He did not use a lot of materials, such as quartz. The presentation was overall chaotic, and some of the results were not understandable. Moving on to the opponent. His presentation was well structured and presented. The questions he asked to the reporter were really relevant. He did mention the lack of relevant parameters such as the weather conditions, and he did notice the lack of details in the experimental procedure. However, he didn't really exist on the reason behind the errors that could have been done in the experiment. There was an inconvenience that was observable. He didn't really insist on the time that the core was in the solution, and he failed to identify the lack of explanation behind the usage of certain materials, such as sugar. One of the main points of the discussion was that the reporter did not really control the weather conditions, but the opponent said that they were important. And we agree with the opponent and that humidity and other environmental factors should be tested and taken into consideration. I'm sorry. In conclusion, the reporter, the presentation was well presented. It was made in a non-controlled environment. There were some possible errors and did not include drafts. However, the opponent had a structured presentation, good speaking skills, and was able to identify the weaknesses of the reporter. Moving on, some suggestions for further improvement. The reporter could have used an Arduino device to control the weather conditions and could just not read off the board. Thank you.
Thank you very much. Opponent, 1 minute for conclusion remarks. Concluding remarks.
I would like to thank the review team for identifying its problem for every team. I would like to say that the biggest flaw was that the slow mats, the properties of slow mats were not present in the presentation. So because of that, the audience does not know how the slow mats should behave, to behave properly. That's what I have to say.
Thank you. Reporter.
Okay, so I want to address some points made by the opponent. So he asked why potassium nitrate was used. Potassium nitrate was used, as I said in my theory, because soldiers used it in the 14th century, and so it would be viable also. So I used sugar to make the cords faster because a cord can have a burning speed without potassium nitrate nor anything. So the sugar made it a bit faster. And also I used a video instead of pictures. And so, yeah.
Thank you. Okay. Some clarifying questions by the jury.
Okay, first of all, I would like to ask the opponent. You mentioned that he didn't check environmental parameters,
Yes.
such as humidity.
Mm-hmm. Yeah.
Is that clear?
He referred it in.
Did you conduct the specific experiment in order to investigate that parameter?
Well, yes, I did in fact investigate the parameters.
Do you find this significant?
Yeah, I found really significant, especially winds. Winds is one parameter that...
No, the humidity. I asked about the humidity.
Humidity. Okay.
Did you check this parameter?
Actually, we couldn't check that parameter because in our case, when we did experiment, the snow mats were stored in bags. So, in fact, humidity was non-existent.
Okay, thank you very much. I would also like to ask once more the reviewer. You have found the presentation structured or chaotic?
The reporting
The
team?
reporters.
Okay, so the reporter, the result and the experiment and the theory, I think that...
No, the presentation.
The presentation itself, some parts were easy to follow, however, at some point it was very hard to follow and there were too many things in one slide, which made it chaotic, which is why I insisted on
Okay,
that.
because you mentioned it was both. And concerning the results of the reporter, of course, did you find them interesting or non-understandable?
It can be both. I found that the results that he presented were interesting. However, if he had presented them both like in the way he talked and in his presentation as in the slides, he could have presented them better and made them more understandable.
Okay, thank you very much.
I have a question for the reporter. You said a lot of times, here are some more graphs. Were they decorative or we were supposed to...
No, they were just to make the data in this huge, yeah, they were supposed to make the data clearer.
We didn't have time sheet.
Yeah.
You just said, here are some more graphs. Next slide. That's all. So we show them as something, as a decoration, not as something that we could conclude to anything from these graphs.
Yeah, because like I had little time.
All right. Thank you.
Thank you very much. Now we have some time for grading. Are the jurors ready? Okay. Please show your marks for the reporter. 23, 23, 22, and 22. Thank you. Please show your marks for the opponent. Okay, now 19, 16, 14, and 14. Thank you. Please show your marks for the reviewer. 9, 9, 8, and 8. Thank you very much. Does anyone want to make a comment?
Okay, starting from the reporter, you presented many graphs, but you didn't explain them at all. And you didn't manage eventually to evaluate the whole process. Concerning the opponent, you made a comment about the environmental parameter concerning the humidity, though you never checked it. That was very important. You didn't conduct the specific experiment. Okay, that's all from me. I said my comment concerning the reviewer.
Okay, I'd like to say a few words about the reporter, who is. Okay, now I see. Well, you said that the diagrams that you not talked about, you didn't explain them. You claimed that time was the problem, but you knew the time. You knew that you had little time, so you could not put the diagrams or say a few words about them, because it's your job. It was an excellent job, by the way. Okay, that's all I want to say.
And maybe I should justify my high grade for the opponent. Which compared to the previous opponent, I thought that you did a better job. So that's justifying the difference, my grade difference from the other jurors. Thank you.
Okay, thank you very much. We now completed stage 2. We have 10 minutes break, and then we'll be back for the last stage. Thank you. We now begin our third and final stage. Is the reporter ready?
Yes, I'm ready.
Okay, please begin.
Okay. Hello, everyone. My name is Menelos Raptis. I'm the reporter from Team Friganiotis presenting the problem number 3, which is called photography with iron salts. These are my contents of my presentation, and this is the problem to be investigated. So, in fact, we should mix 10 parts of ferrous oxalate with 7 parts of concentrated ammonia solution and 20 parts of saturated solution of oxalic acid in order to produce a photosensitive iron complex. We should prepare separately a 25% solution of potassium ferricyanide, and according to the problem statement, a sheet of paper saturated with a mix of these two solutions can be exposed to light and produce an image. So firstly, when do we call a material photosensitive? Photosensitive materials attain properties that are distinctly different from those of non-excited materials. By absorbing energy from light, these materials temporarily change their solid state, molecular, and/or interfacial properties. Okay. The discovery of photosensitivity in 1978 by K.O. Hill triggered a new development of new optical elements, mainly in fibers and waveguides. The principle of photosensitivity relies mainly on the exposure of material with energy larger than its bandgap. The linear or non-linear interaction generates a change of the material structure that induces a local refractive index change. Okay, so firstly, what is generally sound type and why referring to this procedure? Sound type is a photographic printing process that produces a cyan blue print. Engineers use this method well into the 20th century as a simple and low-cost process to produce copies of drawings referred to as blueprints. The process used two chemicals, ferric ammonium citrate and potassium ferricyanide. In the experiment given, we use ferrous ammonium oxalate and potassium ferricyanide. The combination of UV light and the citrate reduces the iron 3 plus to the iron 2 plus, and this is followed by a complex reaction of the iron 2 plus complex with ferricyanide. The result is an insoluble blue dye, also known as Prussian blue, and this is the color change. So in the experiment, what happens is that we have two solutions. In the first solution exists the ferrous oxalate, the ammonia, and the oxalic acid, while in the second one exists the potassium ferricyanide, and when combining them, we will have a solution with iron 2 plus, cations of potassium, cations of ammonia, and of course ferricyanide anions. Okay, so in the experiment we have some interesting combinations. For the first one, we are only interested in the Berlin blue, in the formation of Berlin blue, while the second one, we are interested in the formation of the Turnbull's blue. In my experiment, we have both, and there is also a chemical balance between them. Okay, those are the parameters which I tested. Okay, and to measure all the above mentioned parameters, I use an open source platform which is called Arduino. Okay, and specifically for humidity and temperature, I use the TTH22 sensor, and the circuit I made referring to this sensor appears on the right. Okay, and this is the hypothesis I made. We wait to observe a higher set number with higher concentration of the solutions. We wait to observe better results referring to the contrast control by using papers with a more absorbent surface. Higher temperature means more electronic traps, which means a higher photosensitivity. We will not observe change in the color if we let the paper under a LED light bulb. with a higher speed of the air current with a bigger amount of water to be evaporated. Higher speed of evaporation of the liquid means lower optical density of the final result. And lastly, the lower the pH, the more intense the final result. Okay, it would be very subjective to compare the results only with a naked eye. In this context, we are all looking for something really valid and really scientific. For this reason, I put a projector in the dark room and a distance of 10 meters of the paper in question. Behind the paper exists an Arduino photoresistor. Firstly, I measured the resistance written from the sensor with a paper which has a solution of the problem statement. Then I did the same after the formation of the photograph. The difference between the two results and the comparing of the differences across the parameters changing is a solution to compare the photographs. Okay, and this is my first experiment, the original experiment, in which we observe a negligible difference, and this is why, yes. The problem uses iron 2 plus with potassium ferricyanide. That means we will observe from the start the thermos blue, which is the same in color with Prussian blue, and that is why what we hypothetically wait to see after the exposure of the paper in the UV. So in my experiment, that didn't actually work. That's the second experiment by using ferrous with ferrocyanide this time, and by testing the parameter of pH, and we can see that in the paper with the number 4, in which I used pH equals to 10, we observe a negligible difference, while on the others, we can see clearly that the lower the pH is, the more the difference is. And this is the third experiment I made, in which I tested the radiation. So we can clearly see in the differences that the biggest difference is in the paper which was exposed for the most hours in the sunlight. Okay. And those are some photographs from the experiment of the UV. Okay, the fourth experiment tests the parameter of dry. So we can see negligible differences across the differences. Okay, and that's the fifth experiment in which I tested types of paper, and we can clearly see in the next. Okay, in this slide, the percentage of the difference for each paper, and we can clearly see that the bond paper has the biggest difference from all the others. Okay, that's the sixth experiment. Is the traditional way using ferric ammonium citrate and potassium ferricyanide. So the first one is the original created by John Herschel, while the second one is a variation using more concentrated solution. So and in those two experiments, we can see and spot a plus 7% difference. That's the seventh experiment I made, which is also the traditional way with UV light. And we can also see a big difference, okay? Right, and those are my conclusions. Iron 2 plus combined with ferricyanide gives thermos blue from the beginning. Lower pH means a more intense blue. Usual light bulbs don't affect the color. All solutions work too by giving the Prussian blue. The way of drying the papers doesn't affect really the experimental procedure. Higher temperature contributes to raise of the photosensitivity. FAC with potassium ferricyanide works a lot of times more better than the FAO with potassium ferrocyanide, and higher light intensity and more time of exposure means a more intense result. Those are my references. Those are my possible errors, and I will return if it is asked from the reviewer. So finally, thank you all for your attention.
Thank you very much. Now we proceed with the clarifying questions of the opponent to the reporter.
He said if you want him to call it, he can go back and say again. So he didn't say.
Thank you.
My question was about Darwin, I have to say. I would like to ask you. You said that you conducted the experiment in Darwin, right?
What? In?
You conducted the experiment in Darwin, right?
Yes.
It was altered. Did you make sure that there was no light at all?
Yes.
Okay. And did you use other type of paper?
Of course, we can see it in the previous slides.
Did you use cloth?
No, I didn't test it. It's one of the parameters that I didn't really test it because
Okay.
I've thought that it would not really matter. We can see here the different types of papers I
Yeah,
use.
I saw that, but I
Okay,
don't know about the
okay,
clothes.
okay.
Did you try to experiment with spherical pattern? Because there is another way you can conduct experiment.
Yes, there are many ways that I can conduct my experiment, but if I try them all,
You did not try
yes,
with
right.
it, okay? And did you try to produce cyanotypes of other colors?
Of other colors of the final printing,
Yeah, the final printing.
then it would not be a cyanotype. It would be
Well, I have to disagree with that, but we can.
okay,
discuss,
and that's the reason why it's called cyanotype because
Yeah,
it produces.
I
Okay,
will explain
okay,
later
okay,
in the
okay.
discussion.
I'm waiting.
And you said that you didn't. So yeah. And did you deal with ammonium hydroxide because you deal with a lot of and I lost your.
Yes, no.
Okay, and okay.
I think you do.
You have 3 minutes to prepare your opposition.
Time is up anyway.
Okay, so
No, wait.
I'll start.
Wait a few seconds.
Okay, hello.
Wait.
Okay, the microphone.
Okay, you can start your statement. Okay.
Okay. Hello, everybody. My name is Marta, and today I will be opposing problem number 3, which was presented by Tim Figaniotis. Okay, so the reporter conducted a really well experiment, and I have to say that. He had an excellent definition of the phenomenon, he had a well-structured presentation, sufficient theoretical support of the result. He included a lot of parameters, I have to say, and the experiment was really interesting. However, he had a lot of theory, which was not irrelevant, but some parts were. Okay. So, the design was nice and anyone could reproduce it. You had the great control of the variables and your results were illustrated and the conclusions verified your hypothesis. But however, about the hypotheses that I mentioned before, they were clear, but I think that you could elaborate a bit on that. The experiments were conducted, I think, in a bit of a non-controlled environment. Yeah, you didn't experiment with a lot of salts, but okay, yeah. And you didn't elaborate on them during your presentation. You had no graphs, only tables, and you didn't try to change the color of the cyanotype. The theory was linked to the results. Yeah, as I said before, but of course some theory was relevant to the experiment. We couldn't understand that from your conclusions. So, they were well-defined, almost all the relevant parameters in theory. You didn't experiment with different types of salt, and you didn't try to change the color of the cyanotype. And the most important part was that there were no graphs and only tables. Thank you.
Thank you very much. Some clarifying questions of the reviewer to the reporter and the opponent. Sorry. Let's proceed to the discussion part.
Okay. Shall I open my presentation?
If you want to, yeah.
Okay.
Yes. He did. Because his name was famous. He did have.
Okay. So, how did you make sure that the room was completely dark?
Okay. You are referring to the UV light experiment. Okay.
Yeah.
I have. Okay. Could you go to the?
I'm referring to all the problems because in the beginning you have to keep it in a dark room before it's
Okay.
exposed to the light.
We can clearly see. We can clearly see it here. Are there?
Okay. There's no problem. Okay. And okay. So about the cyanotype, you said that they couldn't change colors, and I have to decide.
Okay.
Oh yeah. Okay. So there was no light at all, only UV light.
Right. And in my next experiment for this, I used a box, so it was closed.
Okay.
Here. Yes.
Okay.
And
So
about the color change.
Yeah, the color
Okay. As I said before in the beginning of my experimental procedure, the problem. Okay. Yes. The problem uses iron 2 plus with. The problem uses iron 2 plus with potassium ferricyanide. And that means, that combination means that we will observe from the start.
Yeah, I didn't say that. I said
Okay.
that if you can change the color. I didn't ask what you did.
The color of the cyan type is, of course, a cyan blue. And it
But
can
can-
change, and it can change, sorry, by testing different parameters such as the light source, the minutes that.
So you think there is no other way that it can change?
I think I mentioned a lot in my presentation.
I mean that you could change the color, but not only blue. You have a lot of different colors by using.
Such as?
You can have green if it's only.
Okay, then we will not.
Sulfide, sulfide, isulfide with sulfuric acid, and was with
I
water and dry.
understand what you say, but if we have the formation of a green color, then we will not have a sound type because the print, the final print, won't be blue.
Color. That doesn't mean that it's not the cyanotype.
So it's not a cyanotype, it's another procedure.
Yeah, I
Okay.
can see that. Okay. Why do you think your first experiment didn't work?
I explained to you a minute ago, the problem uses iron.
There are no other problems that...
No, I think there aren't other problems here. It's just that we observed from the start the term was blue.
Okay, can you go to your errors?
Of course. Okay, those are my
Okay.
possible errors.
And how do you think you fix them? Because you...
Okay, maybe buy a more accurate sensor.
And how would you distribute the solution? Because I think that when you... It wasn't easy.
Okay, with an Arduino maybe machine, it won't have possible errors. Yes, I believe.
Okay, so what do you think will happen if you use more hydrochloric acid?
More?
Hydrochloric acid, you mentioned it.
No, I didn't mention it in my experiment. I didn't use it.
Okay, and what do you think if you expose the time for more time, even more? I know that you expose it for 24 hours, right?
Yes. Right.
So what do you think if you expose it for more hours, or less?
Okay, in my experimental procedure, I say that if we expose it for less time, then we will not have a so intense color of blue. But if we conduct the experiment for a longer time, I don't think that really something will change. Just the color that maybe turns to a more dark blue. But I think 24 hours were enough to test it.
Okay, thank you.
Thank you too.
Thank you very much. Please stand there.
Okay.
Now let's proceed to the clarifying question given to the reporter and the opponent.
May I start? Okay, first question to the reporter. For all your trials, for one of them you said that you used the UV. For
Yes.
the rest of them, did you
UV lab, yes.
UV lab. Did you test all of them with the UV lab or just in that trial?
In that trial only.
So
Yes.
in all the other ones, what light source did you use?
From the sun. And one I was from a LED light bulb in which I answered that it had an, okay.
Thank you.
Anna, please step up there.
Could I ask how many trials did you do?
A lot of trials. My experimental procedure were 7, and the experiment.
Which one you had 7 trials?
No, I had 7 experimental procedure in which I had approximately 5 different parameters tested.
But how many?
No trials. Yes.
Oh, okay. Thank you. And can I ask to the opponent, why did you focus so much on the changing colors of the prints?
No, I just wanted to clarify because he said that in the beginning that it's not possible to change because the cyanotype. That's why I wanted to elaborate on this.
Okay. Thank you. That's it from me.
Thank you. You now have 2 minutes to prepare your review.
Is it done? Oh, I've got one. Is it done? She didn't. Yes, in the opponent, in the thing.
Okay, down.
Stop doing stuff now. Yes.
Don't change anything down.
I'm down.
Okay.
or anything like that.
Are you ready?
Yes.
Okay. Please reset the clock and let's start.
Hello everyone, my name is Anna Alessandro and today I'm going to be the reviewer for the topic photography with iron salts. So here is an outline for the reporter. So, first of all, he explains many terms such as the cyanotype very well and thoroughly. He tested many parameters and he had many experiments. He used an Arduino to collect his results, which was accurate, but they do sometimes tend to lead in inaccuracies. The images, he had many images of all of his prints, and that was good because it helped us understand and it also showed that he did the experiment. Some bad points is that he read from the presentation. His graphs, when he was talking about his results, they were up there and they were too small, and also he didn't reference them. His images needed labels. He did have many hypotheses, but at the end, in his conclusions, he didn't mention if they were proven or disproven. He did mention his conclusions, but he didn't mention about the hypotheses. So some more are that he had many conclusions that he did support with theory, and he did mention errors. So for the opponent, she mentioned that the results were reliable and that they were sufficient and they were supported by the theory. She spotted that he didn't test many iron salts. She said that there were no graphs, I'm pretty sure, but there obviously were graphs in his presentation. She addressed the question. She addressed many questions, and she did not ask about how many trials there were going to be. She also didn't mention that there were no error bars in his graphs, which he should have had since he did 3 trials. So overall, the reporter's experiment was great. There were many things tested. He did many different experiments. He tested so many different parameters. He answered all the questions of the opponent using the theory of his slides. The only thing that he didn't explain is graphs, even though he had them. And the opponent, one of the main negatives was that she didn't have good time management. She didn't really bring her own opinion, except she brought it in the discussion, but not when she was presenting the presentation. She didn't have a full focus on the report, as at times she would ask about things that the reporter hadn't actually done. And that's it. Thank you.
Thank you very much. Some concluding remarks of the opponent.
Okay, first I would like to say about the reviewers' remarks that I mentioned some errors in my presentation. Maybe you didn't see them, but I did mention that he didn't mention the errors, but that he had the errors, but he didn't present them, as you said. And the fact that I didn't notice that, didn't spot the graphs because they were too small and he passed them so fast, so I didn't have time to check that they were actual graphs because he focused mainly on the tables. And yeah, I will have to say that maybe he could have used different iron salts, and maybe because the presentation was a bit too fast, I didn't have the time to see which iron salts he actually tested, because this experiment could be conducted in many different ways. That's what I had to say.
Thank you very much.
First of all, I have to say that it was a really constructive discussion. I insist on that if we observe another color change, then the procedure isn't the sound type. DTH sensor, in response to the team of the reviewer, is one of the most accurate Arduino sensors from my experience with it, and errors existed but were not asked to be presented. That's all. Thank you.
Thank you very much. Some clarifying questions by the jury?
I would like to ask the reporter, what other iron salts are photosensitive? Did you, sorry, but I missed it. Did you mention it also wants to to produce photographs with various iron salts and investigate the role of relevant parameters? Okay. Tell me first about the iron salts that you used.
Okay. In my experiment, I used a lot of combinations of different ways that you can produce a cyan blueprint. In my experiment, the combinations, if you ask it, for the iron salts that I used was ferric ammonium citrate with ferric, and the other was ferrous oxalate with ferrocyanide, with potassium ferrocyanide.
The question exists.
Okay.
What other iron salts are photosensitive? What iron salts did you use?
Okay. The only iron salt I used is one, and I referred to it in my presentation.
So you used one iron salt.
Right. Yes.
Okay. So you did not answer this point of the that you were supposed to answer. Okay, this is one. Okay, I just want to see if you answered exactly because your presentation was to the point. Okay, but there is a question here, and I want to see about it. What did you do? Okay, I don't have anything else to ask.
Thank you. Any other from the jurors? Mr. Voulias? Okay, thank you very much. We'll now proceed with the grading. Are you ready? First, for the reporter. Please show your marks for the reporter. 27, 24, 25, 28. Thank you. Let's proceed with the opponent. Show your marks for the opponent. 16, 16, 15, 16. Thank you very much. And finally, for the reviewer, please show your marks. 8, 8, 8, 9. Thank you very much. Mr. Vroulias, some...
Starting with the reporter, of course you had some problems with your presentation. I mean, the font, the color of the font, totally black, very small sized characters. But your experimental setup was great. You managed to support your results. I liked it very much. The opponent also, you have a great, excellent argumentation skills. You have made a great analysis of the report. Congratulations. And the review, and your review was great as well. Congratulations.
Thank you very much. Mr. Samaras.
About the reporter, it was an excellent presentation. But I wanted to have done, to have answered in the last question, which I told you before. The opponent was great job, okay, but let me say, you could face him a little bit better because the reviewer was right. Sometimes you stay to some details and not to the main subject. This is my opinion. Okay, but you must do your job, although it was only one salt. Okay. Reviewer was to the point.
The final fight is now completed. Congratulations to all of the teams for their effort. We will be back in a few minutes with the final results and to proceed with the award ceremony. Thank you very much. Είμαστε έτοιμοι για την απονομή των μεταλλίων και των βραβείων. Συγχαρητήρια σε όλες τις ομάδες που πήραν μέρος. Ήταν πολύ ενδιαφέροντες οι αγώνες που διεξήχθησαν υπό την αιγίδα της Ένωσης Ελλήνων Φυσικών. Ευχαριστούμε πολύ το Αριστοτέλειο Κολέγιο για τη φιλοξενία, αλλά και όλες τις ομάδες που συμμετείχαν στο διαγωνισμό. Λοιπόν, θα ξεκινήσουμε ανάποδα. Έκτη ομάδα στην κατάταξη βγήκε η ομάδα από το Ιδιωτικό Σχολείο Ράπτου της Λάρισσας. Η ομάδα Ράπτου, λόγω του ότι είχε να κάνει ταξίδι, έχει πάρει τα μετάλλια της και έχει αποχωρήσει. Θα συνεχίσουμε με την πέμπτη ομάδα. Τη βράβευση θα την κάνει ο κύριος Σαμαράς Σταύρος, μέλος της Ένωσης Ελλήνων Φυσικών και συγγραφέας των βοηθημάτων της. Πέμπτη ομάδα στην κατάταξη βγήκε η ομάδα Α. Κάπτεν της ομάδας είναι η Μυρτώ Τερψιάδου, η Μάρτα Καραλιόγιου, μέλος της ομάδας, ο Δημήτρης ο Καφετζής, ο Αθανάσης ο Μετλάρης. Δίνε μου. Έλα εδώ. Πηγαίνετε λίγο πίσω. Παίρνει κάμερα. Εδώ. Πίσω. Από εκεί. Ένας.
Για να είναι και ομάδα μαζεμένη. Ελάτε να σας βάλω.
Πάρτε το μετάλλιο.
Καθίστε εδώ πέρα μαζί. Να δώσετε το βραβείο και βγάλετε και μια φωτογραφία. Ωραία.
Δίνε τα μετάλλια ένα-ένα. Ένα-ένα. Δίνε αστασμένο. Μπράβο. Μετά τα certificates. Βγείτε.
Βγάλε άλλη μια και χωρίς τη μάσκα.
Ευχαριστούμε πολύ. Συγχαρητήρια. Από εδώ, παιδιά, από εδώ. Μπορείτε να κάθεστε εδώ. Λοιπόν. Σαμαράς. Λοιπόν, θα συνεχίσουμε με την τέταρτη στην κατάταξη ομάδα. Τα βραβεία θα τα μοιράσει ο κύριος Γιώργος Ιακωβίδης, μέλος του Διοικητικού Συμβουλίου της Ένωσης Ελλήνων Φυσικών και καθηγητής στο Αριστοτέλειο Κολέγιο. Κύριε Ιακωβίδη. Λοιπόν, τέταρτη ομάδα βγήκε το Ελληνικό Κολέγιο. Συγχαρητήρια. Το Ελληνικό Κολέγιο αποχώρησε, οπότε τη βράβευση θα συνεχίσει ο κύριος Ιακωβίδης με την επόμενη ομάδα. Τρίτο στη σειρά και με ασημένιο μετάλλιο είναι η ομάδα του Ανατόλια. Συγχαρητήρια. Κάπτεν η Ζωή Μαρία Πετρίδου και μέλη είναι ο Νικόλας ο Μόσχος, ο Νίκος ο Οικονομίδης, η Αλεξάνδρα Θεριανού και ο Άγγελος Κιαδάς. Ναι. Η βαθμολογία που πήρε το Ανατόλια στον τελικό με άριστα το 60 ήταν 45. Έχουμε άλλο ένα ασημένιο και ένα χρυσό. Τη βράβευση... Ποιος θα κάνει το ασημένιο? Τη βράβευση της δεύτερης ομάδας θα την κάνει ο κύριος Γκροζούδης, ο ιδιοκτήτης του Αριστοτελείου Κολεγίου. Τον ευχαριστούμε πάρα πολύ για τη φιλοξενία και την υποστήριξή του. Λοιπόν, δεύτερη ομάδα στο διαγωνισμό με 48 βαθμούς και ασημένιο μετάλλιο είναι η ομάδα του Pinewood. Κύριε Γκροζούδη, αν μπορείτε να κάνετε τη βράβευση. Κάπτεν της ομάδας, η Κέλη Χου και μέλη, Άννα Αρσένου, Παύλος Παρασχούδης, Τζον Πότσης, Χρήστος Καλεμκερής και Αλίσσα Οτσέρτσοβα. Συγχαρητήρια, παιδιά. Συγχαρητήρια, παιδιά. Πιο μπροστά, πιο μπροστά.
Εδώ τώρα. Κύριε Σαμαράη, θα μπείτε στο πλάνο ή θα βγείτε τελείως. Περιμένετε παιδιά εδώ. Ο κεντρικός παίκτης, δεν το βλέπω. Το κεφάλι κάτω βλέπω.
Συγχαρητήρια σε όλους. Και τελικά, όπως όλοι καταλάβατε, έστω και με θρίλερ, πρώτη ομάδα με 51 βαθμούς στο τελικό και χρυσό μετάλλιο, the absolute winners, Team Φρυγανιώτης. Κάπτεν της ομάδας, ο Μενέλαος Ράπτης, Ναυσικά Κουταβά, Σωτήρης Μισκάκης, Ευελίνα Γιαλαμά, Μυρτώ Φλωρίδου, Χριστίνα Φαρμάκη και Κλάρα Μαρία Δεμπή. Τη βράβευση θα την κάνει το μέλος του Διοικητικού Συμβουλίου της Ένωσης Ελλήνων Φυσικών, ο κύριος Κώστας Βρουλιάς. Σαν έβδομο μέλος της ομάδος για τη συμμετοχή για την επόμενη φορά. Συγχαρητήρια σε όλους.
Εδώ τα παιδιά μου όλα.
Χαμόγελο.
Χαμογελάστε.
Σαμάρα, γιατί δεν είσαι εσύ?
Κύριε Σαμαρά, περάστε.
Θα τους επισκιάσω.
Δίπλα στον κύριο.
Έλα να με επισκιάσω.
Ελάτε δίπλα στον κύριο Ιακωμένη.
Το χρυσό μετάλλιο θα πάει στον παγκόσμιο τα παιδιά. Με τις ευχές μας. Για φωτιά από 1 μέχρι 6 και μπαίνετε έτσι στο πανεπιστήμιο. Να το θυμάστε αυτό. Αλλά δεν ισχύει αυτό που ισχύει. Δεν διαβάζετε καλά μου.
Αυτό το έπαθλο θα μένει για πάντα στην Ένωση Ελλήνων Φυσικών και κάθε χρόνο θα χαράσουμε πίσω τους νικητές. Οπότε όλοι θα ξέρουν την ιστορία ότι στον πρώτο ελληνικό τελικό κέρδισε η ομάδα σας. Συγχαρητήρια. Ευχαριστούμε πάρα πολύ. Ευχαριστούμε πάρα πολύ όλες τις ομάδες. Η επόμενη χρονιά, το επόμενο τουρνουά, το Second Hellenic Young Naturalist Tournament, ξεκινάει από 1η Σεπτεμβρίου. Οπότε όσοι ενδιαφέρεστε, οργανώνεστε, φτιάχνετε τις ομάδες, αιτήστε στην Ένωση Ελλήνων Φυσικών και εμείς σας προετοιμάζουμε για 2 ημέρες όπως αυτές. Αλλά ο διαγωνισμός δεν τελειώνει εδώ. Το ελληνικό κομμάτι είναι απλώς ένα μέρος του διεθνούς διαγωνισμού, ο οποίος τρέχει εδώ και 34 χρόνια και έχετε την ευκαιρία να αντιμετωπίσετε 40 χώρες από όλο τον κόσμο. Ευχαριστούμε πολύ, να είστε καλά όλοι και ευχαριστούμε πολύ τους καθηγητές μας, οι οποίοι μας βοήθησαν, χάλασαν το διήμερό τους για να είναι κριτές και ευχαριστούμε όλα τα σχολεία που συμμετείχαν. Να είστε καλά.